So today we're going to continue with the rational expressions. All right, so last time we learned how to multiply, divide, and simplify them. Today we're going to learn how to add and subtract. So that's important also regarding these rational expressions. We're going to see how to add and subtract them, find the LCD, and everything like that. This will be used. This is useful because we're going to be using this to solve equations involving rational expressions. That's for next class. Today we're going to see how to add and subtract. Next class we're going to see how to use this to solve rational equations, rational expressions in the equation. So let's start right ahead and talk a little bit about finding the LCD. Or we're going to do a little review on how to basically how to find the LCD. So what we call the least common denominator. Which will be referred to as the LCD. We're going to be using this abbreviation a lot. So the least common denominator. So as you know, when you add or subtract fractions, we need to have the same denominator. For example, if we add in 1/3 and I don't know, 3 or 5/3. So whenever you add or subtract fractions, the first thing you want to look for, you want to check is you look at the denominator. So the denominator is the bottom part of a fraction. In order to add or subtract fractions, you must have the same denominator. Unlike multiplication and division last time, we didn't have to have the same thing here. We just multiplied this way, or we did what we call cube change flip with division. But with addition or subtraction, you must have the same denominator. If you don't have one, you need to find one. You need to find the LCD. So if your denominator is the same, that's good. You keep it the same. You don't add it, it stays the same. You only add the tops or subtract them if you have a subtraction. So for example here, 1 plus 5, that's 6/3. You always simplify your answers. Could be a fraction or could be a rational expression. We learned how to do that the other day. So you want to simplify this. This turns into 2. Same concept applies to subtraction. And so you have 10/7 minus some number here. So again, with subtraction, you must have the same denominator. If you have that, then you keep the denominator the same and you subtract the tops. 10 take away 2 is 8/7. Can't simplify that, it stays like that. You can write it as a mixed number. But that's fine. That's right, it's possible to write as a mixed number, but it's no big deal. So today, we're not interested in that. So basically that's a little review for adding and subtracting fractions. But sometimes the denominator is not the same, so we need to make it the same. For instance, if you have 12 here, and maybe, let's say, actually let's use, maybe if it's a 6 here, and a 4, maybe 5 and 1. So let's say you want to add these two fractions. Can we add them right away? Can we add them right away?
No, we have to find the, we have to find the least common factor.
That's right,
it's going to be 12.
The least common denominator, that's right. So these are not the same. So you can't just do 5 plus 1, 6 plus 4. That's wrong. Don't do that. It seems easy and convenient, but it's not the way you do it. So we're going to find the least common denominator, or multiple for 6 and 4. What's the least common denominator?
12.
12.
That's
12.
right. 12 is the least. If you're thinking about 24, it's not the least. 6 times 4 is 24. is also a common denominator, but it's not the least. We need the least, that means the smallest. So it's not always this times this. You gotta find the smallest common multiple of the two. In this case is 12. Common multiple, or the LCD. Least common denominator or common multiple is 12. So once you find the LCD, so we can turn both these fractions into new fractions with a new denominator, the common one, the least. So this is the least common denominator. Not this one. Although this would be still okay if you use this, but it will be a lot of work. You're going to be dealing with large numbers. So it's better to use the least common denominator. It's useful, as we're going to see later, with fractions, with rational expressions. That's the first step. You find your LCD. Once you find it, so we're going to turn these two fractions into new ones, new equivalent fraction. This one turns into a new fraction. But we have to change this into a new one proportionally. We're going to change 6 into 12. How do you turn 6 into 12? You times it by. To turn 6 into 12, we need to times it by 2. And you need to do the same thing at the top, since you multiply it by 2. Also here by 2, to keep the ratio the same, to keep the proportionality between these two numbers the same. So it's 6 times 2. That's 12. 5 times 2 is 10. So the new the first fraction turns into 10 over 12. Now we're going to do the same thing here.
Oh, okay, okay. I thought that was.
All right, I think I'm back. Can you guys hear me?
Yeah, we hear you now.
Yeah.
I lost connection for a minute. Let me share my screen again. All right, so I was talking about adding these. So we turned this into this fraction. Now we're going to turn 1/4 into a new fraction with 12. How do we turn 4 into 12? Times it by. How do you turn 4
Times 4. 4 times 4.
Not 4 times 4.
3. Sorry.
Times 3.
4 times 3.
On the top, times. If you multiply the bottom by 3, the top.
By 3 too.
Also by 3. Now, 4 times 3, that's 12. 1 times 3, that's 3. As you can see, so we took these fractions, we turned them into equivalent. These are equivalent to these. They're not different. The ratio is the same. It's just new fractions with different denominators. Now that we have the same denominator, just like these, we can go ahead and add. So I'm going to keep 12 here. And here we have 10 plus 3. And that's 13 over 12. Okay, so that's a little review on fractions. So by now, everybody should know their fractions very well. As I told you last time, should know all the rules that involve fractions. And those rules are used for rational expressions, because rational expressions are basically just fractions themselves, fractions that happen to have polynomials. Okay, so now let's see how to do this, but with actual rational expressions. So rational expressions, as we saw before, involve polynomials, binomials, trinomials. So let's say if you have this here. Okay, so we're going to add these two. As you can see here, the denominators are not the same, so we can't add right away. We can't do this yet. You have to make these the same. So what needs to happen here in order to make these two the same? Especially this denominator, we have x1, and here we have x2. How do we make these the same? How do we make these two denominators the same? We need to multiply them by something. What do we multiply by?
By 1?
Not exactly. So we have x1 here, we have x2. We need these to be exactly the same. That means we need this x2, we need this x1, we need to turn it into x2. How do you turn that into x2? Basically, looks like we have to multiply this by x1. If you times this by x1, turn into x2, this is already x2, and we're good. So we times this by x1, and as always, when you times the bottom by something, the top by the exact same thing, in this case x1. 3 times these, you're going to get 3x over x1 times x1, that's x2, plus 5 over x2. Now that we have the same denominator, that's good. We can go ahead and add, as always. The common denominator stays the same, so x2 here stay the same. You just have to add the top, so 3x plus 5. And after that, try to simplify this as we did last time with simplifying rational expressions. Try to factor this, see if you can factor this, and cancel out any common factors. In this case, there's no common factor here. This can't factor, it's not a trinomial. We can't use binomial factoring, and this is already factored. So basically, that's your answer. Okay, so we have to look at the denominators and figure out a way to make them the same. But if you're lucky enough and you have a common denominator already, let's say you have this, maybe plus something else, plus say x1. And let's say you have x here, or just 2x, and possibly 2 here, for example. Okay, so these are two fractions. We try to add them. Can we add these fractions right away? Everybody, can you add these fractions right away? And why?
Which one?
No.
Yeah.
Why not?
You talking about 2x? Yes, we can.
Fun.
Yeah. Oh, what's the
Because they're
first
the same.
when you add fractions? What's the first thing you look at?
Thanks to you, my plan nearly failed before it even began.
What's the first thing you check when you add fractions? You check.
Same denominator.
Right? It has to be the same. If it's the same, that's good. Keep it the same.
But your father used your
And just add the tops. 2x.
So 2x plus 2.
That's right. And after this, try to simplify. What do you do again to simplify rational expressions? What's the first thing you do?
Can cancel out the x's.
We can't just cancel the x's right away. We have to do something else before that. Because we have additions here in addition, we can't just cross out the x's. We need to do one thing before simplifying or canceling out. What is that step? What is that process?
It's not fact.
That's right, we're gonna factor. Try to factor everything, and then if you end up with a common factor, you cancel it out. What is the common factor here?
2.
That's right, 2. And if you factor 2 out, you have x plus 1. This is already factored. There's no GCF, no binomial or trinomial, so it stays the same. And what happens now?
The x plus 1s
What happens
cancel
next?
each other out.
That's right. So these are common factors. Now we can cancel them out. So we have x plus 1 here. We have x plus 1. These cancel out. We have 2 left by itself. Okay, so it's pretty simple when you add. If you already have a common denominator, keep it the same, add. And as always, simplify your fractions. Could be a fraction like this, could be rational expression. Factor first. Okay,
Professor, can you do another sample like that one?
Yep, we're going to do plenary examples. So you factor first, and then you cancel out all the common factors. So that's one way to add, subtract fractions. Let's do another example. This time maybe with So,
Wait, I got one question about the factoring. Just
Mhm.
curious. So
Okay.
it's a 2x plus 2, right?
Mhm.
Where did we remove the 1?
Which one?
Like it's 2x plus 2 equals to 2 times x plus 1. Oh, wait, my bad.
Okay, we factored it.
Yeah, my bad. Sorry.
All right. So here's another example. Let's say you have x plus 5, maybe minus. So we have x plus 5. Maybe some number here. Let's say 4. So you want to subtract these two fractions, but they don't have the same denominator. This one has 2 and x plus 5. This one has just x plus 5. But again, we can't add them unless we have the same denominator. So if you look at these, how can we make them the same? How can we make them the same? One of them is missing something. So what do we need to do here in order to make those denominators the same? How do you make these two expressions the same? You want to make them look exactly the same. What's missing from what that would make the two look alike?
Don't you just multiply it by 2?
That's right. So this one does not have 2. Does not have these two. So again, we need to have identical denominators before we can subtract or add. So this one has 2 and x plus 5. This one is missing that 2 here. See, now they look exactly the same. But if you times this bottom here by 2, what do you do at the top?
You have to times it by 2 as well.
Exactly. Whatever you times the bottom by, you got to times the top as well. That's how you get equivalent fraction. Okay, so you get equivalent fractions. And now everything looks good. So once your denominator is the same, as in here, for example, 12 and 12, or 3 and 3, you keep that the same, okay? You write it once, not twice. And again, subtract the tops. 3 minus 8, which is basically -5 over 2 x plus 5. As always, try to reduce your final answer. Nothing cancels here. If we had, for example, let's say 40 or 6, we would probably reduce that. But in this case, everything is factored. So this is already factored 2 times this and this. Nothing cancels out. So that's your final answer to that. Okay, so again, look if you have the same denominator, that's good. Keep it the same and add the tops. If it's not the same, then you see how to make the two denominators the same. One of them might be missing something, so you kind of complete them until they look exactly the same. And this is very similar to regular fractions. So you need to know your fractions already, okay? At this point, it's assumed that you know how to add fractions, simplify, add, multiply, divide them. The same concept applies here. If you have issues with fractions, it's gonna make it a lot harder. So review your fractions first. I know I do it before I start anything. I already did it here, but make sure you know your rules of fractions, how to find the LCD, how to simplify and everything very well. But that's basically the concept that's used here for rational expressions. Let's do another example here. So now let's see if we have maybe so 3x2 plus here's another example. This one is a little bit tricky. So we're trying to add two fractions. And again, always look at the denominator. It's not the same, so you can't add right away. We have to try to make these the same. There's got to be a way to find an LCD before we can add the two fractions. If you look closely here, the denominator has both numbers and letters. So to find the LCD here, first, find the LCD for the numbers. We have 3 and 6. What is the common denominator for 3 and 6?
3.
12 or 3.
So 3 and 6. Let's say you would add in fractions like this. What is the LCD for 3 and 6?
12.
6.
That's 6.
Oh, 6.
The first multiple or the least multiple of the two, the least common multiple. It's not always 3 times 6, but the number that they both can go into. So the smallest number that you can go into is 6. So that's the LCD. And now, so the LCD, so you start with the numbers. So 3 and 6, so the LCD is that. Then you go to, so basically 3 and 6, they both go into 6. Now we have x4 and x2. Which one of these two, which one of them both can go into? Which one of these, x4 and x2, they both can fit into?
2.
No, they're not going to fit into this one because x to the 4th is not, it's not going to fit here. So usually you take the one with the higher power. Okay, so you have x4 and x2. So you pick the one with the higher power as the common denominator. Okay, 2 steps here. Shouldn't be that complex. So start with the numbers, find your LCD just like you do with the regular fractions, which you should know well. Once you find that for the numbers, then you go to the variables. Look at the 2 and just pick the one with the higher power and you write it down. So that's your common denominator. Okay, the least common denominator. Okay, so as we did here, once you find LCD, now we're going to rewrite the fractions. We're going to turn these fractions into new fractions with this denominator, just like we do with the 12. We're going to turn both of these into new fractions with that denominator. Let's see how to do that. So you want to turn both 3 and 6 into 6. How do we turn 3 into 6 again? To turn 3 into 6, we times it by?
You gotta multiply it by 2.
That's right, just like we do here. So we want to turn both 3 and 6 into 6. So 3 to turn that into this because we want the new denominators. So this fraction will turn into new fractions with the same denominator. Okay, again, it's the same concept as regular fractions. So here, for example, the LCD is 12, so we turn these two into new fractions with the same denominator 12. It's the same idea here. Now let's see how to turn this one into this. So to turn 3 into 6, we said we're going to times it by 2. If you multiply the bottom by 2, you're going to multiply the top by 2 as well. That's the first step. So 2 times 3, that gives us 6. x4 into x4, we times it by. It's already itself, so no need to multiply it. Or you can think of it as x4 times 1. Times 1, because times in anything by 1 doesn't change. So this one is already x4, so no need to do anything. Just this. So if we times, now we have 2 times 3. That's 6. That's good. x4 is here. 2 times 1 is 2. So we're done with the first fraction. We turned it into a new fraction with this. We need this before we can add. Now look at the second one. We want to turn this into that. How do you turn 6 into 6? It's basically already multiplied, or it already goes into 6 once. So it's like, say, in times 1. So 1 times 6 is 6. Then you go times the top by 1 as well. So here's the tricky part. So we want to turn x2 into x4. How do you turn that? X2 into x4. Everyone, how do you turn x2? You times it by what to make it x bar?
2.
Say again? Give me the whole expression. What do you multiply it by? You need to multiply it by x to a certain power, right? So
Yeah.
x to what power?
X to the second power.
Exactly. So we need the second power here. Because when you times, again, the rules of exponents that we saw before, when we times two expressions with the same base, we add the powers. We want to turn x2 into x4, so we say what number multiplies by 2 or adds to 2 to get 4? That number is 2. Okay, now that we added, we'll multiply the bottom by x to the power 2. What do you do at the top?
Multiply by x2 also.
Multiply.
That's right, we're going to multiply by the same thing. Again, whenever you multiply one side of the fraction by something, don't forget to times the other side by the exact same thing. That's how we keep the fractions equivalent. Okay, now let's double check. So 1 times 6 is 6. That's what we wanted. X times x2 times x2 is x4. Very good. 1 times 5.
5 and x2 4.
That's right. And
5x2.
x2.
x2
So that's the important part. As you can see now, we have the same thing. We can now go ahead and add, just like here, for example. Once we turn into 12, keep 12 the same, and add the tops. That's exactly what we have here. So this got to stay the same, the common denominator. We're just going to add the tops here, 2 plus 5x is 7. And that's pretty much it. Again, always try to simplify. So you can factor here. This one is already factored. There's no common factor here, so nothing cancels out. And that's basically the sum of the two fractions. So it's a lot tricky if you have numbers and letters in the denominator, but it shouldn't, again, it's not that difficult. First start with the numbers, look at them as regular fractions, then take the x with the lower power. Let's do another example like that. Maybe with subtraction this time. So let's say we have 5 here. Okay, maybe x to second. 3x to the third. Okay, so pay attention again to this example. It's similar to this one in the same steps. First of all, can we subtract these two right away?
No, wait, are you talking about which one? Nope.
We can't, why not?
Or wait.
Because the denominator is not the same. So we can't subtract right away, so we need to find,
No, you can't.
that's right, we need to find an LCD.
It's gonna be 15.
Okay, so we need an LCD for these two. Again, start with the numbers. We have 5 and 3. The LCD for 5 and 3 is
15.
15. That's the first step. Now we have x2, we have x3.
It's 6.
Nope. Which one do we take as a common denominator when we have two powers? Just like we did here. We had x4, x2. We picked x4. Here we have x2 and x3.
But the least, if you take it with the least, we're gonna take 3.
That's right. We take the one with the higher power. That's the one that they both go into. So 4 and 2. We picked 3. I picked 4. So again, start with the numbers. Find the LCD for the 2. Write it down. Look at the variables. And take the variable with the higher power. Okay, we have 2 here and 3. We're going to take that. That's the first and most important step. Make sure you get your LCD right. The rest is just multiplication. We're going to make the denominators. These two, we're going to make them the same. So you write your new fractions, these, both with the new denominator, not with these, but with the new one, which is a common between the two, common denominator between the two. So 15x3 . Okay, so now let's see how to, so basically we turned this fraction into this one, we turned this fraction into this one. Same thing, now we're going to turn this fraction into a new fraction here. And we're going to turn this one into that. All right, let's start with the first one. We want to turn 5x2 into this. We're going to turn 5 into 15. How do you turn 5 into 15? We times it by. Other one, we want to turn 5 into 15. Or how many times does 5 go into 15?
3.
3 times, that's right. We're going to times this by 3. The top also by 3. Now we want to turn x2 into x3.
It's x1.
That's right, we're going to times it by x1. Why is that? Because when we multiply, we add these two. They should add up to 3. And again, the same thing here. So let's multiply everything now. So 3 times 5, 15. X2, x1, x3, that's good. And we have 3 times 2 times x, that's 6x. Let's do the same thing here. So what do we multiply this by?
1.
Start with the 3. We want to turn
5.
That's right, turn it into 15. So we're going to turn this by 5. Also 5 here. Do we need to multiply the x3 to get x3?
No, yeah, by 1. X.
Already there, that's right. It's already there, so x3. So no need to multiply it by anything. You can think of it as times 1 times 1, but that would change it. So if it's already what you need, then you don't need to multiply it. So now we're going to times these two. So 3 times, or 5 times 3, that's 15. x3 is the same, and 20. Once you have your common denominator, as you can see, that's good. So now we can write that denominator here and just subtract the tops here. 6x, take away 20. And as always, we need to try to simplify our answer as much as possible. Can we factor the top? What is the common factor here?
2.
That's right, we have a common denominator here, which is a common factor, which is 2.
2.
3x, and what else? Minus?
Minus 10.
Minus.
Minus 10.
That's right, divide by, this is already factored. It's one
5.
one term, so 15x.
15.
After you factor everything, see if we can cancel out. Can we cancel anything here? Can we cancel anything here? Do you see any common factors to cancel out?
No.
That's right, there's no common factors. If,
No, it's not there.
right, maybe if we had 8 here, or a 2, or a 6, we could cancel that out. If we had an x here, for example, x2 or x3, could reduce that. But that's it, we have this times this, and this times this. They're all different factors. So that's basically your final answer. So that's how you find the LCD in different situations. So the purpose, again, before adding and subtracting is to manage to make, if they are the same, that's good. If they're not the same, you have to make them the same. One way to do this is this way, like we did, by multiplying one of the fractions or both until they're exactly the same. If the denominator is already the same, that's good. You can just go ahead and right away add or subtract. If not, very important that you find LCD, okay? So adding and subtracting fractions requires the least, it requires a common denominator. The least one is the best to use. Okay, does that make sense to everybody?
Yes.
Yes.
Okay, everybody, any questions? Anybody else?
No, thank you.
Okay. Okay, let's do some more examples or more cases. So far, all we saw here was basically just monomial. We did a binomial here, but it was the same denominator. It's also possible to have a trinomial here, maybe another trinomial or more here, and it's the same idea. We need to make that the same. We need to make the denominator the same before we can add or subtract. Let's take this example here. Let's say you have 3, maybe x plus 2, and plus there are 2 fractions now. Now we're trying to make things a little more interesting. So we have a binomial here, another binomial. Obviously, we can't add right away. These need to be exactly the same before we can add. But this one is a little different. It's not a monomial here, as we did earlier. We have binomials, so we need to find the LCD for this and this. Any ideas on what to do first? Any ideas on how to find the LCD for these two?
What is the
Should
common?
we factor the x squared minus 4 first?
That's right. That's a good idea. So always see if you can factor anything. Here we didn't have to because everything was pretty much factored. We had monomials here. This binomial here was already factored. This one.
No, you have to factor that.
That's right. This one was already factored. If it was 2x and 10 plus 10, then we would have factored it first, but it wasn't. So always factor first. It makes it a lot easier to find the LCD. You can easily find it after you factor. So factor. So factor first. So to find the LCD. So again, all the methods of factoring that we learned are involved here. As always, I keep repeating that you need to know your factoring very well. If you don't know factoring, this will not make much sense. So factoring, again, always look for a GCF. And again, you can go back and watch the couple of videos we did before the couple lectures before the midterm. So try grouping. If grouping doesn't work, you try binomial factoring, and then maybe trinomial factoring. But always look for the GCF first. So this doesn't factor, there's no GCF, it's not a trinomial, there's no difference of 2 squares. So it's basically, you don't have to, but actually you could try to factor the top as well. Maybe you can simplify. If you have something here to factor, try to factor it, maybe you could reduce this. It's always a good idea to simplify any fractions for rational expressions before using them for addition or any other operation. What about this one? Can we factor it?
Yes. It becomes x plus 2, x minus 2.
Exactly. X minus 2. So if there was no GCF, then we used binomial factoring. This is what we call the difference of 2 squares. And we have 5 here, which stays. Good, that's a pretty good step now. If you look at these 2 denominators now, they're not exactly the same. How do we make them the same? So one of them is missing something to look like the other. What is it?
The first one's missing x minus 2.
Exactly. So this one has x plus 2, x minus 2. The other one should have exactly the same. Again, common denominator is the same number or expression. So since this one has x minus 2, this needs it. So we're going to times this one by x minus 2. And since we times the bottom of this fraction by x minus 2, what do you do at the top?
Times it by x minus 2 as well.
Exactly, same thing. Every time we multiply by the same number, 2, 2, 3, 3, same thing here. So x minus 2 should be multiplied on both sides of the fraction. Very good. Do we have the same denominator now?
Yes.
So the LCD here is x plus 2, as you can see. X minus 2, and it's a lot easier to see after you factor. That's why I say factor to find the LCD. So this is now, may look complex to you, but it's actually very simple. It's nothing other than something simple like this. Let's say 4 over 5 plus 2 over 5. Just two fractions with the same denominator. When we add them, again, keep the denominator the same and add the tops together. That's pretty much what this is. It may look like a lot of things and variables, but the concept is this. It's just a simple thing. So we're gonna keep the denominator the same. For example, here 5 and 5. Here we're just gonna keep that the same. Write it once. Okay, so then you add the tops. So here we added the tops. Same thing here. So we're gonna take this top here, 3. X minus 2 plus the other top, which is 5. That's almost the answer. But since we have some expressions here, polynomials, we need to simplify them a little bit. So especially the top, what do you do here to simplify this top?
Distribute the 3 to the x and the negative 2.
So we're going to distribute this and then combine like terms. First of all, you can't just cancel x minus 2 and x minus 2. We can't do that because we have an addition here. If this was a multiplication, we would be able to cancel this and this. But because this is an addition, will not allow us to just cancel x minus 2 and x minus 2. That's the reason why we factor. We have to have all multiplications here because before we can cancel common factors between the top and bottom. So distribute this, so 3x minus 6 plus 5. Then we have x plus 2, x minus 2. Combine like terms, so we're going to combine these two. So 3x minus 1 over the same denominator. By the way, you don't have to distribute the denominator. Always leave it factored. It's useful this way. No reason to write it back as it was, because when we keep it this way, we may use it to cancel out. For example, here you may end up with a common factor here between the top and the bottom, which you can cancel out. So never distribute this back. Always leave your denominator is factored, but the top, if it's possible to simplify, you can do that. Combine like terms and everything. So you have x plus 2. And as you can see, nothing can be canceled out, no common factor. But if, for example, for some reason you had, let's say, x minus 2 here, just for hypothetically speaking, after simplifying this, after doing some stuff, you end up with something like this, then you can just cross these out. It would be convenient. That's why you want to leave this factor. You don't want to distribute it back, okay? Just in case we end up with a common factor. But in this case, it's I'll put it back where it was. We end up with something like this. Okay, so nothing to cancel out, and that would be your final answer. Okay, so again, check your denominator first. If you don't have a common denominator, find one. And to find one, always factor first. Factor your denominators, both of them. So again, you need to know your factoring very well. You need to know your fractions, basic concepts of fractions very well. Those combined together are used here in this, in adding rational expressions. So once you factor, you can easily see complete both denominators until they both look exactly the same. You may have to multiply both fractions. Sometimes you just multiply one. Okay, for example, here we have to multiply both fractions. Other times you just need to multiply one fraction. So depending on the denominators. So let's do another example like this. quite similar example, okay? Maybe I'm gonna throw in some trinomials now. Let's probably use a trinomial and a binomial, but we're gonna use this pretty much the same concept, okay? So remember, factor, and then find LCD. And after that, of course, we simplify. Okay, so to get from here to here, we simplify. And see if we can end up with maybe some common factors. Okay, so pay attention again. The next example will be similar to this. So number 4. All right, so x plus maybe 5x. All right, here's another interesting one. Again, this may look intimidating. Doesn't have to. As long as you know what you're doing, it should not scare you. Just gonna do a couple of things which we know. Okay, a couple of things that we already done. We already know different subjects in different classes. Basically, we're gonna combine those together and solve this problem, just like we did with this one. All right, so what do you think we do first here? Everybody, can we subtract?
Gotta factor first.
Gotta factor this, right? We can't subtract right away. As you can see, we have different denominators. And in order to find the denominator, what do? Let's
You have to factor them both to find the common denominator.
exactly. We're gonna factor here. Makes it easy to see the LCD. You can't just, for example, you have x2. You can't just add 6 here or add 5x plus 5x to make them the same. You can't find a common denominator by adding to both denominators. You have only multiplication can be done when you try to make the LCD. For example, if you have 1 over 7 and you have 1 over, let's say, 9, these are different denominators. You can't make them the same by adding 2 here and adding 2 to make this line as this line. That's very wrong. Don't do that. You will have to multiply both or one by a number, not add. So same thing here. You can't just add 5x here or something to make it look like this and then add something here to make it negative positive 6. Nope, it does not work that way. So you have to multiply. And before multiplying, we're going to turn these into multiplications. And to do so, we do what we call factoring. Again, keep emphasizing how important factoring is. It's very useful. And let's see how to add these two or subtract them. So this is going to be pretty long, fun expression, but again, just because it's long or has more numbers and letters doesn't mean it's difficult. All right, how do you factor this denominator here? Again, when you factor, you look for a GCF first. If you don't have a GCF, try grouping, try binomial, try trinomial. So what do you do here? How do you factor this denominator here? X to the second plus 5x plus 6. Trinomial factoring. What is that equal to? Everybody?
Don't you multiply them?
It's not.
We want to factor this, but we're not multiplying it. Again, to find LCD, factor first.
So first factor is gonna be x minus 3.
Nope.
I mean the second ones, not the first ones.
Well, let's do the first one first. So factor to find out.
So we just take x
How do you-
from it.
How do you factor this one? How do you factor this trinomial?
Don't you take the x from it?
What is it equal to? What is that? Again, I thought we talked about this in detail before the midterm, and
You put, Professor, you
What
put
is the
x plus 5,
so we have
x plus 5,
x,
x.
we have 5x and 6. What numbers go here?
5 and 6.
Nope.
Oh, we had to find a number that gives
2 and
5
3.
and also 6, right?
2 and 3.
That's right. Two numbers are multiplied to this and add up to 5.
Okay, okay.
You guys need to know these things, okay? We can't repeat them every time. So again, make sure you know your factoring. That's useful. Then minus, what's the other?
X minus 3 x times x plus 3.
That's right, x minus 3x plus 3. Finally, 7 here. That's the first step. We just factored yet. We don't have the LCD yet. We just factored. Let me try to write this a lot bigger. So again, we have x plus 3, x plus 2 here. Here we have x minus 3, x plus 3. Obviously, they're not the same here, as you can see. We can't subtract yet because we don't have a common denominator yet. So we factored, that's good. Now, let's see how to make these look exactly the same. Start with the first one. This one is missing something that this one already has. What is it? This denominator here is missing something from here.
X minus 3.
Exactly. So we need, this one needs to have that x minus 3 as well. So I'm going to put it right here. Good. So now this one has 3 factors. This one has only 2 and is missing something. What is it missing? This one here.
X plus 2.
That's right.
2.
X plus 2.
X on 2.
It needs to have that x plus 2. Again, the denominators must be identical, have to be exactly the same. The order of the factors don't matter. The order here doesn't matter, but as long as you have all the factors. Because when you say 3 times 2, for example, times 5, is the same as 5 times 2 times 3. Okay, these are identical. We call the commutative property of multiplication. So don't worry about the order. You don't have to be in the exact same order, but as long as you have same factors, that's all we care about. Good. So let's call this the LCD. Okay. So this is our LCD. This is not a fraction. Just means. So this is our LCD. So that looks like we're missing something. We need to do something else here and here too. What is it? Looks like we need to do something else, especially here. What is that? What is missing?
The X,
What is it?
the X take away 3.
That's right. So if you times, again, one side of the fraction by something, you have to times the other side as well. What about this?
You have to times the top by x plus 2.
That's right, x plus 2. It looks like a large fraction or a complex fraction. But again, this is just a very, nothing bad here. Just like something, let's say 5 over, I don't know, 8 minus 1 over 8. This whole thing is the same picture as this. No big deal, same denominator, this one here. We have something here minus something. So all we have to do is keep this the same. We're going to write it once. We're going to turn this into one fraction with the same thing. I don't want to write the whole thing again. I'm just going to write LCD, which means these three factors. Okay, as we saw it earlier again, once we have the same denominator, you write the same denominator and you add the tops. That's what we're doing here. We're going to keep that the same, just like here. This will be 8, right? 5 minus 1. That's the bigger picture of this complex expression. Okay, so LCD the same. Now we're going to take the top minus the other top, just like 5 minus 1. Let's take this. Don't distribute yet, just write them down. Okay, so we take this minus this here, 7. We're almost done with this one. What do you think we do next? We're almost done with this answer of this expression. One more step. What is it? We need to
Distribute.
That's right. Let's distribute here. Let's simplify. Again, the LCD is this. I didn't want to write the whole thing again, so all these factors. And again, we can't just cancel this -3 with this one. You can't cancel this x plus 2 here from x plus 2 here, again, because we have a subtraction. If this was a multiplication, all multiplications then would be able to cancel out. But this one, we can't just cross those out. We need to distribute this and combine like terms. So this is 3x minus 9. Then negative here, it's important, that's a negative, -7x. Negative times a positive, that'll be positive, or negative 14. Okay, so distributed, this is still the same. Let's just save a lot of time and just call it LCD, because it's long LCD. Now we're gonna combine these. 3x minus 7x, that's 4x. Okay, -4x, and then combine the other two, -9, -13. That would be negative what? Negative 20. 23, right? Over. Same thing again, the LCD. And again, the LCD refers to this, so saving a lot of time and space by not rewriting it multiple times. Then again, after simplifying, see if we can factor here. Maybe we can end up with a common factor between this denominator and something from here, but it doesn't look like we have a common denominator here. I mean, a common factor other than -1. So that's basically the answer to that. Okay, so this is probably as complex as you can get, but the steps are pretty much the same. The steps for the concept, depending on the expression, could be as simple as this. Already have the common denominator. Maybe a little more complex with some binomials, or some binomials like this with different powers. But if you see binomials, trinomials in the denominator, again, it doesn't have to be that bad. So remember to factor and then find the LCD. And the two most important tools that we used here are the factoring. So again, if you don't know factoring, you wouldn't know what you were doing here. And also you need to know your fractions, especially if finding the LCD and stuff like this. So those combined together help us solve a problem like this, adding or subtracting. And this is, we're gonna use about 90% of this for the next class when we solve equations like these. So we're gonna take equations with something like this. For example, equals maybe 0 here. or equals some expression. We're going to see how to solve equations like this. And we're going to be repeating this basically. So make sure you understand this well, because this is going to be used almost in its entirety to solve rational equations in the next class. Okay, any questions, everybody? Does anyone have a question at this point?
No questions.
Everybody, please make sure you understand this. It's not as complex as you think. We just combine a few topics together. So make sure you understand each one of those topics in order to be able to understand what's going on here. Okay, everybody, does that make sense at this point?
Yes, understand.
Yeah.
Okay. I highly recommend that you rewatch this. Some of you need to rewatch this at your own pace. Just review it again. Watch it 2, 3, 4 times, however many times you need, until it sticks. Yeah, you're gonna see plenty of examples here in the homework. Something similar to this. And if anything, okay, when you rewatch this, when you do the homework, please write down any questions you don't understand. By next class in the beginning, let me know. Let's see, so the homework should have a bunch of these. Yep, you'll see plenty of these in the homework. I just wanted to do one last one here. Let's say you have, say you have, just you have X. Just maybe 1 plus. So you may see something like this. So again, we want to add these two. As you can see, these are different. And as you can see, we can't factor them. They're already factored. So to find LCD, basically just each one is missing the other. So this one, so no factoring is necessary here because they're already factored. We will write it again. So basically we have X plus 3 here. That's X minus 2. We have 1, and we have 5. Okay, so basically what we have here is, since we can't factor, there's nothing else we can do unlike these. So basically each one of them is missing the other. So this one is missing this, so we're gonna multiply this one by this one, X minus 2. Also X minus 2 at the top here. And this one is missing the other also, X plus 3. And also X plus 3 here. And that's pretty much it. We have the same denominator, so we're going to keep the LCD the same here. Then combine these two, so we have X minus 2. We have plus 5X. And plus 25, if you distribute. Combine like terms, we have 4X here. We have these two, negative 23, or positive 23. Over the same number here, the LCD. The LCD meaning this, okay? LCD meaning this. And always try to simplify. As you can see, we can't factor this to cancel out. That's basically your answer. Instead of the LCD, you could write